In this video, I am going to solve this problem. We are given the following. If omega is a complex cube root of unity, then find the value of this given expression. Here we are dealing with cube root. So that means we are looking for all the x values such that cube root of x is equal to 1. If I take cube of both sides, then I am going to get x cube is equal to 1. So in essence, we are looking for the solution to this equation, x cube is equal to 1. Now as you may already know, the solution set for this is, by the way, x is equal to 1, then x is equal to negative 1 half plus I times square root of 3 over 2. By the way, I is square root of negative 1, as you know. And then the third solution is x is equal to negative 1 half minus I times square root of 3 over 2. So these are the three solutions, or these are the three cube roots. Now they tell us that omega is a complex cube root. So for our calculations, I am going to assume that my omega is going to be negative 1 half plus I times square root of 3 over 2. By the way, I could have assumed the other one too, like this one. It wouldn't have made any difference. So I just picked this one. Now let's make an observation here. The observation is this. Omega is this, right? So by the way, omega is the same as negative 1 half plus I, by the way, is square root of negative 1 times square root of 3 over 2 is equal to negative 1 half plus square root of negative 3 over 2. Why did I do that? Because this kind of looks like this. Now we are going to be able to simplify the given expression and find a value. We are given this. Now we can simplify it. If we simplify it, we get the following. Technically, I am not simplifying it. Actually, I am making it a bit more complex. So let's see what I have done here. So just take this part of the expression. I am going to multiply it by 2 and multiply it by 1 half. Now 2 and 2 technically cancel out as if you are not doing anything to it. Why did I do it? So that I can get the structure to conform with the structure of omega. So now 2 times 1 half is under the square bracket that has been raised to the power of 7. So if I factor out the 2, I am going to get 2 to the power 7 outside. And then I am going to distribute this 1 half. So 1 half times negative 1 is negative 1 half. Then 1 half times negative square root of negative 3 is square root of negative 3 over 2. And then similarly, I do the same thing on the right hand side. Let me label this as 1. It's not an equation, I'm just labeling it as 1. So now what I'm going to do, I'm going to do something interesting. I have omega is equal to negative 1 half plus I times square root of 3 over 2. And I'm going to try to square it and simplify it. If I do so, I get the following. I have done a bunch of calculations here, so let me just break it down for you. So let's look at it right here. So omega square is the square of this thing, so which is this. Now I use a plus b whole square formula to simplify it, which is a square plus 2 times a times b plus b square. So that's my negative 1 half whole square, which is 1/4, 2 times a, which is negative 1 half b I times square root of 3 over 2 plus b square I times square root of 3 over 2 whole square. If I simplify it, I get 1/4 right here, look here, 1/4 minus I times square root of 3 over 2 plus I square times 3 over 4. Now as you know, I square is, by the way, negative 1, right? So if I put that value, I get the following. I get this, then I combine the constants, and finally I get omega square. By the way, look, my omega is this value, my omega square is this value. They are conjugates of each other. in case if you forgot what a conjugate is, in complex number world, if a plus ib is a complex number, then a minus ib is the conjugate of that number. So basically change the sign in front of the complex or imaginary part. So change the sign in front of the imaginary part of the complex number. Remember, this is called the real part of complex number and this is called the imaginary part of the complex number. So a plus ib, a minus ib, they are conjugates of each other. And by the way, if you recall, we got three solutions for cube root of x. The complex numbers are complex conjugates of each other. So basically, this is one of the solutions of the cube root of unity, and the other solution is this one in addition to 1, right? So these two numbers omega and omega square are their complex conjugates of each other. Okay, so that's the interesting part. And now what I am going to do, I am going to take this value and plug it in right here. If I do that, I am going to get the following. Is going to be 2 to the power 7 times, now this by the way is nothing but omega by our assumption. So it's going to be omega to the power 7 plus 2 to the power 7 times this, by the way, we found it to be omega square. So it's going to be omega square raised to the power 7. Now if I simplify it further, it's going to be, I can factor out 2 to the power 7 from both of them. Then I'm going to get the following, omega to the power 7 plus omega square raised to the power 7 is going to be omega to the power 2 times 7, which is omega to the power 14. Now, here is another piece of information that you need to know, which is this. If omega is a solution to x cube is equal to 1, that means omega cube is always going to be 1. So, in general, if omega is a solution to x to the power n is equal to 1, okay, then omega to the power n is always going to be equal to 1. So if omega to the power, in our case, omega to the power 3 is 1, then omega to the power 6 is going to be 1 too. Why? Because omega to the power 6 is omega to the power 3 whole square, right? Which is, we know omega to the power 3 is 1 or omega cube is 1. So 1 square is 1. As a matter of fact, any multiple integer power of omega, positive of course, is going to be 1. So let's say omega cube is going to be 1, omega to the power 6 is going to be 1, omega to the power 9 is going to be 1, omega to the power 12 is going to be 1, omega to the power 15 is going to be 1, and so on and so forth, right? Now what I am going to do, I am going to write it as 2 to the power 7. So this I am going to write it as 2 to the power 7 times omega to the power 6 times omega plus omega to the power 12 times omega square. What I have done, I have broken it down into two pieces where I am factoring it out in such a way so that it cancels. So this, by the way, is going to give me just 1. This is going to give me 1. So I get 2 to the power 7 times omega plus omega square. Now I got to find what is omega plus omega square. This, by the way, leads to another very interesting property for the solution set for cube root of unity, or in general nth root of unity, where n is greater than 1, a positive integer. So in our case, our solutions were 1, omega and omega square, right? Remember, omega was this one, the negative 1/2 plus I square root of 3 over 2, and omega square is negative 1/2 minus I square root of 3 over 2. By the way, if you add all of this, and you can check it, if you add all of this, you are going to get 0. Now from this one, we can solve for omega plus omega square by subtracting 1 from both sides. So omega plus omega square is going to be negative 1, because I am subtracting 1 from both sides. 1 cancel out, and that gives me this value. Now I'm going to take this value and plug it right in here. So that's going to give me 2 to the power 7 times negative 1, which is nothing but negative 2 to the power 7. If you want to simplify it further, you can do so. By the way, this is going to be nothing but negative 128, because 2 to the power 7 is negative 128. I mean, negative 2 to the power 7 is negative 128. Now this is how you'd solve this problem. Now let me summarize what I have done here. I was given this problem where omega is a complex root, cube root of unity, and I needed to find the value of this expression. And what I did, I found the three roots of unity, which are this, this, and this, and I call this guy omega, and then this becomes omega square. Then I take this thing, the given expression, and simplify it to the point where I can replace the values by omega or omega square. Okay, and I do so right here, where so on this I replace it somewhere here, right there. Okay, then I simplify it, and I simplify it to get to this point, where right here, this one. Okay, and I simplify omega to the power 7 plus omega to the power 14 to omega to the power 6 times omega plus omega to the power 12 times omega square, but omega to the power 6 is 1, omega to the power 12 is 1, so that comes down to omega plus omega square. But some of the roots of the unity, in our case cube root of the unity, is going to be equal to 0. From there we solve for omega plus omega square, which is -1, and I plug it into here to get -128. I hope that this discussion was helpful. Thank you very much.